Okay, our objective now is to formally prove this whole triple is true using what we've built up so far in the previous video. So we've got these two logic statements here. We'll need this later on for the precondition strengthening part, and we'll need this later on for the postcondition weakening part. So I've copied those here, we'll need them later. And we're also going to use this property here, P and B, S and P. We want this, we want to be able to prove this property, right? What was that property? It's going to be this whole block of code here. So what we'll do is we'll write our goal at the bottom, and then copy in this P and B, S, and then P business. So we'll write that here in the middle. T equals I factorial, and I is less than or equal to N. So this part here, just to keep in track, that's my P. And B, I is strictly less than N, and then the 2 bits of code. Increase I plus by 1, multiply T by I. And my postcondition is just P by itself. So T equals I factorial, and I is less than or equal to N. Okay, so maybe to keep track, I should just write in the corner what P is so we don't forget. So what was P? P was T equals I factorial, and I is less than or equal to N. Cool. So now I've got that so we don't forget. So I need to both prove this statement, and from this statement, try and get down to here. Okay, so we'll do this part first, that's the easy part. If I want to get from here down to here, so this is B, I can use the while rule forwards. So what's the while rule? Here it is. So P, T equals I factorial, and I is strictly less than N. While B, so while I is less than N, do the code, I plus 1, T is assigned to be T times I. Now postcondition is P and not B. So P, T equals I factorial, and I less than or equal to N, and not B. So just write negation of that. Otherwise it won't fit the rule. Okay, so that's perfectly fine. So now our objective is to take this thing and clean it up so it looks like this thing. Okay, so what have we got? Well, really I should rewrite this exactly like this. So instead of I greater than or equal to N, I'm going to write negation of I less than N. There we go. So this statement here implies this statement here, because we did that work before. Therefore, I can weaken my postcondition, right? I can replace my postcondition with something weaker. So T equals I factorial, and I less than or equal to N. While I is less than N, do blah, 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 blah. The same code as before. And then T is equal to N factorial. So that's going to be my postcondition weakening. I'll fill in the line numbers afterwards when everything's finished. I also should move this over a bit because it's a little bit blurry. There we go, that's a little bit clearer. Give me a moment. There we go, that's better. And now the other thing that's changed from here to here is the precondition. And thankfully I can use precondition strengthening because this statement here implies this statement here, because this is a stronger statement. So I can jump from here straight down to here by precon strengthening. Okay, so I managed to get from here down to here. That's the easy part done. Now the tricky part, proving this statement here. How do we prove this statement? Well, it's got no while rules in it, but it's got 2 bits of code. So if we check my rule sheet again, if I want to prove something with 2 bits of code, I'm going to have to use the sequencing rule. So I'm going to use the sequencing rule backwards here. So we're going to get 2 statements to prove. T equals I factorial, and I is less than or equal to N, and I is strictly less than N. So all of this junk. Actually, first off, it'd probably make more sense to do precondition equivalence. So I think I'll do that first, because this is redundant. So, I'm just going to turf that. There we go. I is equal to I plus 1. T is equal to T times I. And then postcondition. T is equal to I factorial, and I is less than or equal to N. Just get rid of that redundant little thing in there by precondition equivalence. And now we'll do sequencing on this. So I'm going to get T is equal to I factorial, and I is strictly less than n, the first bit of code, increase I by 1, and then some mysterious q will work out in a second. The same mysterious q, t is assigned to be t times I, and my post condition. T is equal to I factorial, and I is less than or equal to n. Okay? How can I figure out what q is? By doing the, doing the assignment rule backwards. So replace t with t times I. So t times I is equal to I factorial, and I is less than or equal to n. So this is true by assignment. Now copy the same q over. T times I equals I factorial, and I is less than or equal to n. How are we going to prove this? I can do the same trick. I can try to do assignment rule backwards. So I'm going to write my post condition up here. T times I equals I factorial, and I is less than or equal to n. Replace I with I plus 1. Doing it backwards. So we're going to get, what are we going to get? T times I plus 1 equals I plus 1 factorial, and I plus 1 is less than or equal to n. Okay, so this is true by assignment. Now I've got to be able to get from here down to here, and the only way I can do that is by strengthening the precondition. So it better be the case, if I can assume this, can I derive this? Let's just sort of like crank that out in the margin. So let me get some scrap paper to work on here. So if I have t equals I factorial and I is strictly less than n, and I want to derive this statement here, I have to derive both of these properties. So to get the first property, I could just multiply both sides by I plus 1. So t times I plus 1 equals I plus 1 times I factorial. And then by the definition of the factorial operator, this is the same as I plus 1 factorial. I plus 1 equals I plus 1 factorial. Cool, so the first property is true. What about the second property? I need I plus 1 is less than or equal to n. Well, I've got I is less than n, which means I plus 1 is less than or equal to n. Cool, that was easy, right? So assuming this, I can indeed derive that. That's good. So we've got if t is equal to I factorial and I is strictly less than n, that implies t times I plus 1 is equal to I plus 1 factorial, and I plus 1 is less than or equal to n by maths. Okay, now I can fill in all the gaps on the line numbers because my proof is done. So that was logic, that was logic. 3, 4, 5, 6, 7, 8, 9, 10, 11. So this was precondition strengthening by lines 3 and 4. That was assignment. What in God's name was this? This was sequencing. These two parts match. So we can go from here straight down to here with the 2 bits of code in between. So sequencing 5 and 6. This was something. I've forgotten what it was now. Oh, precondition equivalence, because this statement here is the same as this statement here, so we should write that out. T equals I factorial and I is strictly less than n if and only if t equals I factorial and I is less than or equal to n and I is strictly less than n. By logic, I guess 7.5 because I missed a line number. This is precondition equivalence by 7 and line 7.5. This is going to be the while rule by line 8. I'll use a different color just because it's kind of squished in. So while line 8. This is post-condition weakening because I'm taking my post-condition and I'm replacing it with something weaker. So post-condition weakening by lines 9 and 1. And this is precondition strengthening because I'm replacing the precondition with something stronger by lines 10 and 2. There we go. Not too bad. A little bit laborious. But again, though, the worst part of this was actually finding the damn invariant in the first place. This is usually the hardest part. Once you've got the invariant, doing this proof is easy. It's actually tracking this guy down that's the tricky part. So in this case, what was our invariant? This was our invariant here. T equals I factorial, and I is less than or equal to n. And how did I find it? By like running the code through a bunch of loops and seeing if I could spot a pattern. Unfortunately, in general, there's no better method than that.